Now coming to the hotspots. So these hotspots will form due to the non-uniform current distribution over cathode surface. Okay, there are three terminals for SCR. They are anode, cathode and gate terminals. So due to the non-uniform current distribution over cathode surface, the hotspots will form. That too when dia by dt, that is rate of change of the current through the SCR, that is nothing but anode current, is greater than spreading velocity of charge carriers. Okay, so these local hotspots dominantly occur during rise time interval because during rise time the di by dt is more. Okay, and so the power loss is also more in that duration. So hotspots are nothing but due to the loss, right? So hotspots means the device is getting heated up. The heating is always due to the losses. So as those losses are more during rise time interval, the hotspots are going to occur during rise time interval only. So if you observe that graph drawn between I and T, I have shown hotspots increases as di by dt increases. Di by dt is nothing but slope for this graph because the change in y variable to the x variable, that is di by dt, means that is slope here. So as the slope is increasing towards the left side, as I have mentioned with arrow, the hotspots will increase. Then coming to the turn off duration, that is there are basically two turn off times. One is device turn off time and another is circuit turn off time. So circuit turn off time is nothing but the time provided by the circuit to turn off the SCR. Okay, but device itself is going to have some certain turn off time. That is nothing but device turn off time. And if that circuit turn off time is greater than the device turn off time, that is nothing but the required condition for that to turn off. Yes or no? That means if you don't provide the required time to turn off the device by the circuit, how it is going to get turned off? It can't be possible, right? That's why the circuit turn off time should be greater than device turn off. Otherwise, we can't turn it off. That is the reason. And what is meant by this device turn off? So it includes two times, that is reverse recovery time and gate recovery time. This reverse recovery time is due to the external layers, that is the recovery of external layers of the device. Similarly, gate recovery is nothing but inner layers. For inner layers it is. And as I have mentioned, the circuit turn off time should be greater than the device turn off time for reliable turning off of the device. Fine, this is very important. Okay, right. Proceeding to the protection of the SCR, we will see two important types of SCRs, that is inverter graded and converter graded. So in case of inverter graded SCRs, the devices or those SCRs will be faster. Faster means the turning off time should be less. That's why if the device turn off time is less than or equal to 50 microseconds, those SCRs are known as inverter graded SCRs. And inverters, choppers, step up cycloconverters come into this type. Then the second type is converter graded SCRs. It is the opposite one. That means it is the slower one, and so the TQ will be greater than 50 microseconds. And in this case, phase control rectifiers, AC voltage controllers and step down cyclo converters will come, right? And if temperature and current through SCR increases, turn off time is also going to increase, because to recover it, turn off time is nothing but recovery time, right? Reverse recovery and gate recovery. So these will be more if the temperature and current are more, because it will take much time to recover, right? That is the reason. Okay. And gate characteristics of SCR, these are very important. Many problems will be asked based on this. So if you see from the circuit, if you write a KVL, ES is equal to VG plus IG RS. VG is nothing but the voltage across the gate, and E is the applied voltage, IG is the current through the gate, and RS is the resistance, right? Series resistance. And the power of the gate is equal to VGIG, okay? And if you observe this graph, the load line is there and gate cathode characteristics are there. So the slope of gate cathode characteristics is nothing but Vg by Ig, because Vg is y-axis and Ig is x-axis. So the slope will be obviously y-axis by x-axis, nothing but Vg by Ig. And the slope of load line will be Es by Rs. That is the applied voltage divided by current. That current is nothing but Es by Rs. So the slope of load line is going to become Rs. That is the series resistance. Okay. To the protection of SCR. So the protection of any device should be done using some components. So here in one circuit I have mentioned all the components and their purpose in protection. So coming from the left side, the first component is CB. CB is nothing but circuit breaker, and it is useful for overall protection of the device. Then comes FACLF, that is nothing but fast acting current limiting fuse. The fuses are not are basically for over current protection. Generally we use in our homes. And then we have an inductor. Inductor is for di by dt protection. And then in middle there we have SCR, and above SCR we have heat sink, that is for dissipating the heat losses. And then at the gate side, gate protection circuit is there, and at the gate one resistor and capacitor are connected, and they are for noise protection. And one resistance is there, that is for limiting gate current. And one Gina diode is there. What is the purpose of Gina diode? That is voltage regulator for the gate. Okay, because for supplying gate current you need some voltage, right? That should be maintained or regulated. So we need to use Gina diode for that purpose. Then towards the right side we have one resistor in series with the capacitor, that is for dv by dt protection, which is known as snubber circuit. This is very important. We are going to see how those parameters should be determined. Then we have a varistor, which is nothing but a variable capacitor, that is not variable resistor, okay? And that will be used for over voltage protection. So here I have mentioned all the components which will be used for different types of protection in case of SCR. Then coming to the snubber circuit parameters, and also inductor L for di by dt protection. So how to determine the values, or how to design these parameters? So the inductor will be designed such that it will be equal to Vs by di by dt, right? And the resistance is the ratio of dv by dt by di by dt. So okay, these all derivations will be there in textbooks, and it is easy to remember also, because vs equal to l into di by dt. From that equation you are going to determine l, right? Now the relationship between these rs, c and l is nothing but rs equal to 2 delta into root l by c, where this delta is damping factor. Okay, so from this relation, if you know any two values, you can find out the other parameter. Okay, so these three equations will be used for all determining all these three parameters, three unknowns, three equations. That's it. So okay, so in some typical problems or options, you may find the solution may not be there. So in that case, how to choose the proper value of option? So basically, for better operation of SCR, RS has to be increased, capacitance has to be decreased, so that the time constant remains constant. Okay, so if you don't find the correct answer in your options, you need to choose options such that the RS value is greater than the value which you have determined, and the capacitance is less than the value which you have determined. Fine. So in options we may not have the correct values, some better values should be taken. Better values may be present. So you should be in a position to consider them with this criteria. Okay. The last topic in protection, that is heating and cooling of SCR. So the junction is a middle part. Then comes the casing. Then above that we have heat sink. Above that we have ambient, that is environment, where it has been kept, the SCR has been kept, right? Okay, middle one is starting from junction, then casing, then sink, then ambient. So here I will present some analogy between electrical quantities and thermal quantities. Okay, so these might you might get in engineering services, match the following. So that's why I mentioned here. So in case of electrical, charge is nothing but heat energy. In case of thermal, similarly voltage difference is the temperature difference, and electric current is rate of heat transfer, and the units are watts. It is not electrical power watt, it is rate of heat transfer watt. That is important. Fine. And the electrical resistance is nothing but thermal resistance. Therein thermal case, and in electrical case resistance is nothing but volt per amp, and so the thermal resistance will be degree centigrade divided by watts, because the voltage is temperature and charge is heat energy. Sorry, the current is watts, so the resistance will be degree centigrade divided by watt. It's very simple. Fine, that's it. Thank you.